So I'm picking up where I left off with notes 7.2. Nobody's in the house, so hopefully I can get through this without too many interruptions. We finished off after graphing reciprocal functions. I'm going to Desmos real quick. Our basic function looks like this: y equals 1 over x. That was the reciprocal function, or the parent rational function. So in general, remember that the reciprocal, or the inverse function, sometimes as it's called, is undefined at x equals 0 because we can't divide by 0. All right, so dividing by 0 is not allowed. In other words, what do you divide into 1 when you multiply it by 0? 0 goes into 1 how many times? And it doesn't. The reciprocal inverse function has two asymptotes at x equals 0, which is your y-axis, and y equals 0, which is your x-axis. And the numerator a in y equals a over x determines whether or not your graph is in the first and fourth quadrants, or, I'm sorry, the first and third quadrants, or the second and fourth quadrants. It determines how far away from 0, 0 you are. And it also, actually that's it, because when a is negative, when a is less than 0, your graph is in the second and the fourth quadrants. Yeah, so that was my son asking me if he can stay later at the neighbor's house. Okay, so now we're going to look at what happens to our function when we add other components to it. So what happens to our basic reciprocal or parent function when we add other components? So h and k. Now this should look familiar to you because we've dealt with h and k when we were dealing with parabolas, and when we were dealing with, let me throw an a in there, and when we were dealing with absolute value functions. So h comma k was our vertex in those. In this case, h comma k is the intersection of my two asymptotes. Okay, so instead of it being the vertex of my graph, you can kind of think of it as the quote-unquote vertex of your asymptotes, the intersection of your asymptotes. So you will always have an asymptote at x equals h, and you will always have one at y equals k. Now that'll vary a little bit as we get into in a different form. It looks a little different than that, but when it's in this form with the plus k, the k is always going to be your asymptote. So to graph them, start by graphing their asymptotes. So I like to use h of a to represent the horizontal asymptote and v of a to represent the vertical asymptote, because I get tired of writing them all the time. So in this case, my vertical asymptote, remember, is the k value. It's the value that you're adding or subtracting. Think about what does the y-intercept do in an equation of a line. It moves your line up, moves your line down. So this is the same thing. It moves your horizontal asymptote up or down. So it is y equals -1. I don't want to put an equal sign there. Let's do. So at y equals -1, I put my horizontal asymptote, and my vertical asymptote occurs where the denominator equals 0, because we're not allowed to have that. That would make the denominator, or make the equation, undefined. So that is at x equals -2, and some of you will see it's always the opposite value in your factor here, or in your expression. So I go to -2 and I draw my other graph. Now I look at a. A is -4, and remember, when it's a negative, that means my graph goes from being in the first and third quadrants to being in the second and the fourth quadrants. So it's going to be here, and it's going to be here. Now notice it's not exactly the same quadrants anymore, because we're no longer centered at the x and y axis. We're centered based on these asymptotes. So now general rule of thumb is to pick values on either side of your asymptotes to get a general feeling of where your graph is. Again, and you can also find x-intercepts and y-intercepts. That's another option. So if I wanted to find my x-intercepts, that's when y equals 0, and my y-intercepts are when x equals 0. So the y-intercept's the easier one to find. Plug in 0 for x. Negative 4 over 2 is negative 2. Negative 2 minus 1 is negative 3. So one point I can graph is 0, negative 3. So 0, 1, 2, 3. There's one point on my graph. Now, another point that I could find is I want to find one on the other side of my asymptote. So if x and y, so we know that when x is 0, y is negative 3. So let's see, this was x equals negative 2. So what if I do, I don't know, negative 3 for x? So I come back to my original equation. I plug in negative 3 for x. Negative 4 divided by negative 1, that's positive 4. Positive 4 minus 1 is 3. So I plot the point negative 3, 1, 2, 3, positive 3. That gives me a feeling of where my graph is going to go. Now the reason why I didn't continue on with the x-intercept is I'm going to show you a little bit later how to solve an equation like this. Right now we don't really know how to do it, so we'll just go without. And so I know my graph has to open this way because it has to approach both asymptotes but not touch them. So that's how you would sketch the graph. Again, you can do this on Desmos, but Desmos will not tell you your asymptote, so you have to know how to find the asymptotes from the equation. All right, moving on to the next example. Y equals 3 over x minus 2. Again, the first step is to find my horizontal asymptote and my vertical asymptote. And our formula is x minus h plus k. K is my horizontal asymptote. So my horizontal asymptote occurs at y equals negative 2. And my vertical asymptote occurs where the denominator here equals 0. Well, that equals 0 when x is 0. So that's our y-axis, that's our vertical asymptote, and our horizontal asymptote is at negative 2. Now I look at A. A equals 3, and remember when A is positive, your graph is in those first and third quadrants. So that means my graph is going to be up here and over here. And then the next step is to plug in a couple of values for x and y, and plot points on either side of the x equals 0 line. So I'm going to try 1. When I plug in 1, that's 3 over 1 minus 2. 3 over 1 is 3. 3 minus 2 is 1. So I plot the point 1, 1. And then I will do negative 1. 3 over negative 1 is negative 3. Negative 3 minus 2 is negative 5. So negative 1, 1, 2, 3, 4, 5 is my other point. And again, I understand the nature of the graph. So I know it approaches the asymptotes, but it won't touch them. And you can pause the video. So number 3, again, the idea is to find the asymptotes first. So in this case, I don't have a k here. There's nothing on the outside, so that's considered 0. So my horizontal asymptote for this one is the line y equals 0, which is our x-axis. My vertical asymptote is found where the denominator equals 0. So my denominator will equal 0 at negative 4. sorry, that was the wrong one. X equals negative 4. 1, 2, 3, 4. So again, this acts as the center of my graph again. In general, I should graph a point on either side of my asymptote. I'm going to choose, for this one, I'm going to choose 0 for x, because that's an easy one to do. Negative 1 over 0 plus 4 is negative 1/4. Granted, it's a fraction, but that's okay. So 0, negative 1/4 is probably maybe right about there. So my graph is going to do this. And then I know my other graph is going to be over here somewhere. And again, I'm just going to pick a value at random. And I will do, let's see, this is negative 4. So I'll do, let's do negative 5. Negative 1 over negative 5 plus 4. I have to do the denominator first. So that's negative 1 over negative 1, which is positive 1. So negative 5, positive 1. So my sketch was a little off. Now, what I haven't talked about was domain and range. So domain and range is based on your asymptotes. Again, they're pretty easy to find. So looking at these particular graphs, for number 2, my domain would be all real numbers except that value that makes my denominator undefined, except x cannot equal 0. And my range would be all real numbers except my horizontal asymptote, so y cannot equal negative 2. For number 3 down here, my domain would be all real numbers except for the value that makes it undefined, which is negative 4. So I say x cannot equal negative 4. That's supposed to be a negative 4. And then my range is all real numbers except where y equals 0, because y cannot equal 0. All right. Let's see, I think the next part is graphing other rational functions. Yeah, so I will stop here for part 2.